Okay, so we'll have a look. Okay, I do it here lah. So quite clear. Again, this is a third order. Hold at z equal to 2. Okay, so again, this is the third order, so I have to use the same formula as the sound. So my residue here will be 1 over 2, limit of z approach of 2, and then d square over this z square. Okay, I don't do it like this lah. I direct cancel each other lah. Cancel each other because z minus 2 power of 3 and z minus 2 power of 3. I left only the ETZ. So when you differentiate 2 times, differentiate, this one is e power of tz, z is a small one. So when you differentiate with respect to z, you have t etz. Again, you have t square etz, so t square etz. So when you put 2 inside, that means you will have 1 over 2 t square e to t. Okay. Try to have a look. If okay, proceed to the number 9. When is midterm? Okay, midterm test will be week 8. Now it's week what? Week 5 or week 6? Assignment will be week 11. Yes, correct. Now it's week what? Week 6 or week 7? Week 6 or week 5? Test will be week 8. Okay, now it's week 6. Okay, you wait a while. You try to continue first. I check the coverage of your test. Okay, form C. Your test should cover chapter 1 and 2, but somehow because we missed 2 class there, so will be okay lah. Then I think I push the test to week 9 lah. Okay, so that you have at least 2 weeks to study lah. Okay, chapter 1 and 2. complex variable and numerical methods. uh, Let me think. Cannot lah, because I have to make the form in the system, so I cannot simply make only one chapter, 1 and 2. Now it's only we just finished chapter 1 only, because we miss out two chapter there, 2 weeks there. So chapter 1 and 2, chapter 2 easy one, no worry lah. But it's numerical method, not that difficult, but you need a lot. You need to do a very long one. Okay. Oh yeah, one more thing. Later we need to do another two replacement class, but I'm not doing so first lah. I will leave it to the end of before end of semester, because I want to see whether we have enough time or not. If we do not have enough time, maybe I will do it like face to face. Okay, because since hybrid lah, hybrid. Okay, because some of you you want to have a face to face class. So maybe that two class I will let it on the behind lah. Okay, make it on the behind, so that we can do the face to face or hybrid class there. So that you can direct face to face. If you have any questions, you can direct ask me. Okay, but that one will be later lah. But in your system, I will request to do the replacement on the Saturday first. But that one is just for system requirement because the system required me to set up the replacement class earlier. Cannot be so late. But we do it later lah. Just for the system requirement, I just do it in the this coming Saturday. But we have no class there. Okay, this one just for the system purpose. Okay, can Okay. So just don't care about the maybe your system letter will show you have class on the Saturday and next Monday evening, but just ignore it. Okay. So I will proceed to the next questions. Okay, number 9. By using the Cauchy residue theorem, I want to evaluate this one. Okay, a square. So what we see here, the pole, okay, simple pole. Simple pole is 8, z equal to -2, and z equal to 1. Okay. Okay, so this one, a square with a vertices. I do the A first lah. Huh? The square with vertices -1 minus I. -1 minus I is somewhere here. -1 plus I. -1 plus I is somewhere here. -3 plus I. -3 plus I. So it's somewhere here. Agak-agak lah. Huh? Okay, -3 minus I is somewhere here. So when you link them together, you will have this one. Okay, but your pole is what? Your pole is -2. -2 is here. And 1. So only this one is included in A. Okay, so when you want to find this one, okay, when you want to find this one, so it's also equal to 2 pi I times the residue. Okay, we just need to find the residue first. Residue of your F at z equal to -2. So we look back. So this one is simple pole lah. Okay, simple pole. So okay, so this one is simple pole, so -2. So it will equal to, because it's simple pole, but this one is not easy to differentiate. Okay, so I will use this one. So limit of z approach of -2, z approach of -2, and then z minus z naught. Z minus z naught, that means z plus 2 and z plus 2 we cancel each other. So I left only z square after cancel and then z minus 1. So I put in -2, I will have 4 divided by -3. So -4/3. Alamak, I just not take the answer as well. Oh, good. Yeah. Okay, -4/3. So what is your answer there? This one will equivalent to 2 pi I times -4/3. So your answer will be -8 pi I/3. Okay, so now you turn to think the question B. Okay, so again, you have to find out where is the location. Okay, z plus I. So normally it's here, but z plus I, that means shift. Shift to where? Shift down a bit. So now the center is at the negative I. Okay, so 3. 1, 2, 3. So be something quite big lah. I use this one. Roughly is something like this. Okay, so z equal to negative 2 and 1. Okay, 1 is here. Okay, negative 2 is somewhere here. So should be both is inside. Both is inside, that means you have to find out the residue of F1 also. 2 just negative 2 just now I found already, so no need to do it anymore. Okay, but now I need to find the 1. Okay, F for 1. So it will become limit of z approach of 1 and then z square divide by, because z minus 1 and z minus 1 cancel each other, so left z plus 2. Okay, let me think. Negative 2 to, okay, we'll try to see whether it's inside or not. Negative 2, that means it's negative 2 and 0. This one is 0 and negative 1. We try to see that distance is less than 3 or greater than 3. So it will be 4 plus 1 square root of, yeah, should be inside. Yeah. Okay. So this one, when you put 1 inside, so I will have 1 over 3. So that means this one will be, this one will be equal to 2 pi I times your 1 over 3 minus of your 4 over 3. So it's negative 1. So I get negative 2 pi I. Okay. Try to have a look. If okay, try to proceed to question 10. Okay, so I proceed to the last questions. Please ask if you have any questions. Yes, inside the circle. You need to make sure it's inside the circle. That's why I try to calculate whether this one is greater than 3 or less than 3. Okay, if the distance of this one and this one is less than 3, that means it's still inside the circle. If greater than 3, that means it's more than the radius, then it's outside the circle already. You must make sure the residue, the point you want to find, is inside the circle. So that's why I think I'm not sure about the C, but maybe you can, okay, you can have a look for the C. This one actually should be something, I think one of the simple pole is not inside this circle. But I'm not sure lah. You try to see lah. Okay, question 10. Okay, the same thing lah. The same thing as number 9. For C, you mean, I think so lah. But I does not check lah. You can check on your own. Okay, so this one, I do the question 10-1. 10-1, so again, I have dz divided by this one, I can take out the z. So that I have I have z plus 6i. Okay, so I saw the simple pole is at the z equal to 0. Z is equal to negative 6i. Simple pole, so it's the first order of simple pole. Okay, so but you have to have a look what is the C as well. C is a unit circle and is centered O. So that means it should be something like this. I, negative I, 1, negative 1. So quite clear lah. Negative 6i is somewhere very down there. So it's not inside the circle. So I no need to care about this one. I only care about the z equal to 0. Okay, so I only need to calculate the residue of f inside the 0. So since this is a simple pole, okay, this is a simple pole, so I can use the formula of limit z approach from 0. Okay, z and z cancel each other. So I left only 1 over z plus 6i, which is equivalent to 1 over 6i. So what is this one? Should be equivalent to 2 pi I times 1 over 6i. I and I cancel each other, so I left pi over 3. Have a look and try for number 3. Okay, so I proceed to the third one. Third one, okay, I want to integrate this one, cotangent of 1 over 4 z dz. So cotangent, that means this one is tangent is sine over cos. So cotangent is cos over sine. So if you want to make sine of 1 over 4z equal to 0, that means 1 over 4z will be n pi. That means your z will be 4n pi. Okay, so simple pole at z equal to 4n pi. Okay, so if you want to z equal to 4n pi, so that means you have a lot of simple pole. But again, because it's unit circle, so when your n is 1, then it's already over. Okay, it's 4 pi is more than the negative 1. It's more than 1 already. So that means the only answer will be n equal to 0. It's inside the circle. Okay, it's only the z n equal to 0 is equal inside the circle, so that means z equal to 0. Simple pole. Simple pole is z equal to 0. Okay, z equal to 0, so I want to find the residue. Residue of f0. Okay, so f0, so it will become limit of, okay, this one I don't want, I direct use the last one. Cos of 0 divide by differentiate this one, I will have 1 over 4 cos 0 as well. So cos 0 divided by cos 0, so this one is only left 4. So the answer, that means this one, okay, is equal to 2 pi I times 4. So it will be 8 pi I. Okay, have a look. Okay. So any questions before I proceed to the chapter 2? Okay, I don't proceed much in the chapter 2 lah. Just brief introduce lah. Maybe just a small subtopic. So any questions? So if you have no questions, then I proceed to chapter 2. Okay, we will just have a quick look on the chapter 2 lah. Huh? Okay, chapter 2 is numerical solution. Okay, what we call numerical solution, when we talk about the numerical, that means there are a lot of equation or a lot of system we don't have the answer. Okay, we don't know how to solve it, or we don't have any appropriate way in order to solve it. So what we do is we try to use a numerical way. Numerical is we try to get the approximate answer, maybe up to 3 decimal, 4 decimal. Okay, I think for engineering should be enough already if 3 decimal or 4 decimal. Okay, of course for mathematician normally they will take up to like more decimal if possible. Okay, can up to billion. Like for example, the pi. Until today, they still trying to calculate the pi by using the numerical way. Okay, up to billion decimal. There, they're still trying to get the appropriate answer. Okay, but I think for most of the engineer, most of the time, 3 decimal is already quite accurate for them already. Okay, so now we have a look. What is numerical solution? Okay, so for this is a numerical solution for system of linear equation. What is mean by system? System means you have more than one. Okay, for example, how are you going to solve 3x plus 5y is equal to 16, and 3x minus 5y is equal to -4. How are you going to solve this one? Okay, maybe you will tell me, okay, I can substitute. Okay, I can get the x equal to 16 minus 5y divided by 3 and then substitute into the second equation and hence I get the answer. Or you can say, okay, I take the first equation plus the second equation, okay, and then I get the x. Or first equation minus the second equation and then I get the y, and so on. Okay, these all the ways you said, okay, elimination or substitution is means by analytic way. What is mean by analytic? The answer you get is a correct answer. It's a very, very accurate answer already. Okay, cannot be more accurate anymore. Okay, so this is called analytic. When we set numerical, I just agak get my x and y. Okay, I try to get my x and y agak only. I cannot get, I just estimate only. I cannot get the very, very accurate one. Okay, so this is called numerical for the system. This is system of linear equation. Can be power of 0, can be power of 1. You have, and for example, this one, you have two equations. Okay, you have two unknown, that means you at least you need two equations. Okay, if you have n unknown up to xn, that means you need at least n of equation. Okay, so we also can express our system, okay, into the matrix form. Okay, so into the matrix form, that means we can expand it into the not expand it try to express it in the ax equal to b. What is your x? Your x will be x1, x2 until xn. And then what is your a? Okay, your a will be a square matrix. Sorry, wait me for 1 minute. 2 minutes. Okay, so what is your A? Your A will be A11, A12, A1N, A1, A21, A2. So it's a collection of your A. So it's a square matrix. So, and then equal to your B. Your B is this one. So it will become a system. It will become a matrix, okay, in the form of AX equal to B. So when you want to find the X, become the inverse. Inverse matrix of B, but sometimes in order to get the inverse, it's not. Okay, our target is to find the X. A and B will be given. Okay, so before we proceed to there, okay, we just have a look. A square matrix is said to be diagonal dominant. What is diagonal dominant? Okay, 5, 5, 1, 2. 1, 1, 1, 4. Okay, diagonal means this one, okay, 5 must be greater than 1 and 1 must be greater than 1 plus 1. Even this one is negative. 4 is, okay, negative 4. Negative 4 because we need modulus. So 4 is greater than 1. This is called diagonal, okay? So for instance, y, okay, we check 4, 11 plus, okay? So we try to Jacobi and Gauss-Seidel. I'm sorry, that's not so that I lost connection. Where I stop? Have I this one? Diagonal dominant. Have I finished it? Okay, can. Okay, I just very brief lah. Okay, so let's say we have a system like this. Okay, we have a system like this, and then we can make it into the matrix form. System that means I have something like this lah. Okay, this is called system. And then linear of equation, that means it's power 1, power 1, power 1, power 1. Can be power 0, but cannot be power of 2. Only can be power of 0, power of 1. Okay, this one, that means we have two unknown. Two unknown, you need at least two linear equation in order to get the answer. Okay, so this one is if you have until xn, so that means you have n unknown, x1, x2, x3. So that means this one will be your unknown. Okay, and then if you have n unknown, that means you need n equation. Okay, n equation in order to get the answer of x. Okay, so we can make this one. This is a system. We can make this one into the x equal to b. X equal to b, where your a is a11, a12, a1n, collection of your a, and then your x is the thing you want to find. X1 until xn, x1 until xn, and then the b will be b1 until bn. Okay, so that means now you have the system. Actually, if you want to find the x, the easiest way is you move your a to the back, become a inverse. But sometimes it's very difficult for you to get the a inverse. Okay, in some metrics. So we have numerical way in order to solve it. But before we proceed to the numerical way, we have a look what is diagonal dominant. Diagonal dominant, that means something like this. Your 9 is greater than 2 plus 5. Your 6 is greater than 2 plus 3. Don't care about the negative. 20 is greater than 3 plus 9. So your diagonal is the greatest number among each row. So this one is called diagonal dominant. Okay, not diagonal dominant. For example, this one 4. 4 is less than 11 plus 5. So it's very clear this is not diagonal dominant because 4 is less than this one. Okay, so in order to solve this one, we have two methods. One is called Jacobi method. One is called Gauss-Seidel method. Okay, so what is Jacobi method? Jacobi method is we use this formula. Today I'm not going to show you how to do that, but I just show you the example and the formula lah. Okay, so what is this? Just very simple. We have a look on the example. This one. Okay, in order to use the Jacobi method, you have to make sure your A is diagonal dominant. So what we do is we take out A become 5, 1, 2, 1, 5, 2, 2, negative 3, negative 5. So this one is your A. What is your X? X1, X2, X3. And then what is your B? 13, negative 9, negative 8. So we check 5 greater than 1 plus 2, 5 greater than 1 plus 3, 5 greater than 2 plus 2. So this is diagonal dominant. Diagonal dominant, that means we can use Jacobi method. So what is Jacobi method? This is a formula. Maybe you will think it's very difficult, but actually it's very simple. What is important is you have to get this one first. Okay, we have x1, x2, and x3. How are you going to get the x1? Okay, how are you going to get the x1? You have this equation. So now you want to get the x1, so you just move everything to the back. So 13 minus x2 minus 2x3, and then divide by r. Divide by 5, divide by 5. That means you will have this one. And then this one, you want to get x2. How are you going to get the x2? Negative 9 minus x1 plus 3x3. So you have this one. But you have to divide by 5 as well, divide by the coefficient of this one. And hence for the x3 as well. Negative 8 minus 2x1 minus 2x2, and then divide by negative 5. But because it's divided by negative, so you move in, become positive, positive lah. So that means now you will have this one. And the rest you just put inside so that you get the decimal. Only when it is diagonal dominant, then you can proceed with this one. And then normally they will tell you what is the initial point. Okay, if they doesn't tell you, then you just assume your initial point is 0, 0, 0. Okay, what is mean by initial point? Okay, because you want to get the x1 r plus 1. Okay, x1 r plus 1, you need to have the x2 r, x3 r. So initial point, that means I try to assume this one is start with 0. Okay, 0, 0. So I will get x1 when it is 0, 0, then I will get 2.6. 0, 0, I get 1.8 or negative 1.8. 0, 0, I get 1.6. So now you have x1. Your next target is you have to find the x2. That means the second round. Sorry. Okay, x1, x2, x3 of second round. So second round, how? You have this one already, is it? So you put inside. You put inside here, put inside here, put inside here in order to get the second round, which is given here. Keep repeat, keep repeat. Okay, when you have the second round, you can do the third round. Okay, and then when you have the third round, you do the fourth round, and then fifth round, and then sixth round, until when, okay, only you stop. You found that they are changing in very, very small. Okay, this one is only changing in less than 0.01. Okay, this one is also the same, less than 0.01. This one even smaller, less than 0.0001. So the changing is very small, okay, and is negligible. Okay, we can just ignore it. Okay, then we stop there. Then we take the last one as our answer. So this one is our approximate answer. Any questions? Yes. Always ignore the negative sign in order to check whether it is diagonal dominant or not. Ignore the negative sign because the formula, you check back the formula is here, modulus, modulus. So we don't care about the negative sign. Any question? This is called Jacobi method. No question? Okay, no questions, then I proceed again. Next one is called Gauss-Seidel. I just tell you these two methods and then later you try to do lah. Okay, Gauss-Seidel method and Jacobi method actually is the same. Okay, it's the same thing, but a bit different is, okay, so now I get this one. Again, need to be diagonal dominant. Okay, just now is x1r plus 1 is x2r, x3r. x2r plus 1 is x1r, x3r, but here they change to r plus 1. That means, okay, in order to proceed to the second round, when you want to do the second round, you have x1, then you direct use. Not like just now. Just now, although you have the x1 r plus 1, but when you calculate for x2 r plus 1, you still use the last round answer. This one, no. Once you have the new answer, then you can direct use already. Okay, so when you do the x3, you have the x1, x2 already, so you direct use it. Jacobi is not. Jacobi is after each round only we replace all the number with the new number. Gauss-Seidel, no. Gauss-Seidel, once you have the new answer, you direct replace. Okay, Gauss-Seidel will be faster. Okay, compared to Jacobi. Gauss-Seidel will be faster, but when you replace the number, you need to be very careful. Okay, but basically the idea is the same. Okay, so you can see when you have x1, okay, x1 0, you use 0, 0, 0. So I get 2.6. But once you calculate for the x2, okay, you can use the 2.6 you have already. X3 you still don't have, so you have to use the last round one. Okay, but x1 you have already. X1 you have 2.6, so you have to put in 2.6 already. You understand what it means or not? Can you understand what it means? Quiet means okay or not? Okay lah, I assume quiet means okay lah. Okay, so today I'm not going to continue, okay, because the rest will be I mean the rest will out of the Gauss-Seidel and the Jacobi. Okay, so you can try. Okay, so now you can try to do the question. I just left it to you lah. Question one, this one. The one. You do this one. Okay, you have to take note. There are some If you direct tag, you will found that 1, 7, negative 1, 5, 1, 1, negative 3, 2, 7. If you direct tag this one, you will find that this is not diagonally dominant. Okay, this one is not diagonally dominant. So you have to think how you're going to change two equations. Okay, for example, I change these two. So become 5, 1, 1, 1, 7, negative 1. Then it is diagonally dominant. Then only I can start with the Jacobi and also the Gauss-Seidel method. Okay, so try to do the question 1, 2. Question start from question 2, no need to do first. Only do the question 1, 2. And then maybe next week we can look together. Okay? Any question before I stop the class today? Okay. Yeah, about the table, yes. When r equal to 1, okay. X1 R is okay, 2.6. Let me see. Okay, I think you are talking about the Gauss-Seidel method, is it? You are talking about the Gauss-Seidel or you are talking about the, let me see, yeah, negative, you are talking about the Gauss-Seidel, is it? Okay, so the formula is this one. So now I know the X1, 1, X1, 1 is 2.6, that's what I said already. And now I want to calculate for X21. So according to the formula, it should be negative 1.8 minus 0.2 of X1 also lah. Okay, that means negative minus 0.2 times 2.6. And then plus 0.6. Because I still don't have X31. So I only can take the X30. What is X30? 0. So I times 0. So negative 1.8 minus 0.2 times 2.6. That's why they get the answer 2.3. Negative 2.32. I try. See whether they get correct or not. Yeah. That's why they get the negative 2.32. Ah? You're not talking about the Gauss-Seidel. Okay. Let's see the one at y r equal to 2. R equal to 2. Jacobi, let me see. You mean this one, is it? X12, 2.32. Okay, how I get 2.32? So how I get 2.32, I use back this one. So I want to get the X12. X12 will be 2.6 minus 0.2 X21 minus 0.4 X31. So X21 is what? X21 is negative 1.8. So I put in negative 1.8 here. X31 is what? 1.6. I put in 1.6 here. So I get 2.6 minus 0.2 times negative 1.8 minus 0.4 times 1.6. So I get the answer as 2.32. This is how they get the answer of 2.32 here. Am I answering your questions? Jacobi, you use a 1, 1. That means when you calculate for the second round, you use the first round one. Okay. So if not any more questions before I end the class here? So if you have no questions, then we stop here today lah. Okay. Next week, whatever we stop, then our exam will be there. Okay, will be include whatever taught in next week. Okay, thank you. Thank you.